Okay, the sine law. I'm actually, it's probably my favorite trig lesson in all of high school. I'm not making that up. Students seem to like it. It's really neat what happens. However, I'm going to try and teach two things at once. Yes, I'm going to try and teach the sine law, but I'm also going to try to teach how to manage a math lesson that gets away on you. Because I think this first page is going to get away on us. As I'm explaining it, you're going to go, what are you talking about? And then I'm going to show you how to manage it, okay? So you don't have to try to manage it on your own. I'm going to manage it with you, if that makes any sense at all, all right? Let's just proceed as if I think this is the easiest page ever, because that can happen in math and certainly in physics and chemistry next year. The teacher acts like it's no problem, but meanwhile, it's a major problem. And I'll go through it, and then I'm going to get sidetracked and do what you should do next year when things get out of hand, okay? Because it's not going to be too tough. Come on. You made it this far. It's not going to be, the lesson's impossible. I can't possibly do it. There must be a disconnect there, okay? So here I go. My imitation of someone who thinks this page is really easy. Even though it's not. Even though it's not, okay? Sine law. I'll be able to use the sine law to solve problems involving non-right angled triangles. Aren't you excited? Apparently, the trig we do this year will also handle triangles that aren't right angled. Aren't you excited? Yay, thank you. The sarcastic cheer, that's good. All right. Here's what we know in this triangle, and here's what we do. If we get given a triangle that's not right angled, what we can do is draw a line right down there. I almost said right down the center. It might not be the center, but the perpendicular there, the altitude we called it earlier in the course, yes? Just draw that, and then immediately I have two right angled triangles, and then I can just do right angled trig. So you go, so what you're saying is, our method of doing non-right angled triangles is to divide it into two right angled triangles. Yes, but there's a major league shortcut, like, oh my, shortcut coming in the middle of all this. If I do that, watch what happens. Over in this triangle here, sine B is opposite over hypotenuse. Now look carefully, and this is where things can get off the rails a little bit as I write this, because there might be too many letters bouncing around your head. Sine B in that triangle means that sine B is h over c. Don't let the h confuse you, and you're thinking hypotenuse. No, h, the height of the triangle. That's why I was trying to get you to write HYP at least when you did short forms. Otherwise, it can get confusing. Sine B would be h over c. That part of the story is over. Seems not very helpful. Okay? Then I went over to the other triangle and I said, how about if I do sine C? And sine C would be h over b. And old math teacher trick coming here. The trick's old, not the teacher. Let me say it again for you gigglers. Old math teacher trick. The trick is old. I can find h using the left-hand triangle, and that would be c times sine b. I can find h using the right-hand triangle, and that would be b times sine c. And here's the old trick. Both those h's have to be the same. So I can make a new formula with no h's in it. It's basically substitution. You saw substitution in previous chapters. I'm going to use substitution and go, oh, that means c times sine b equals b times sine c in any triangle that you go to look at. Doesn't have to be right angled, because now I've dropped the height thing I did there. The altitude is gone. It got substituted out. That's not how you usually see it written. Usually what we do is we take the c and move it over here to divide by c, and the b and move it over there, and you get the beautiful sine law. In any triangle, I didn't say in any right angle triangle, in any triangle, sine b over b equals sine c over c. One little detail. Here's how we name triangles from now on. If that's big B, we're going to name the one opposite it little b, straight across the triangle. You'll find triangles from now on will always be labeled like that. And so we did it with C's here. It's difficult with C's because C, capital C and little c look the same. You'll see when I go to do it, I'll do a giant C for the angle. IC, good one. And then the A is the same thing. It's a little bit easier. It's totally okay if you look at that one, you lost me somewhere on the way though. So here's what you do. After a lesson like that, you don't freak out. You don't go, oh, maybe I can't do this course. Maybe I don't belong in physics. I don't belong in chemistry. You just slow down and you go and you try to do this. And I'm going to try and do it on a separate page. You can decide whether you want the separate page or not. I'm going to use this and I'm going to do it all with numbers instead of letters. Okay? So I've got a new flip chart ready to go. And I'm going to draw a triangle and try and do this with numbers. In fact, I wouldn't scramble to copy this down. Just watch what I do. And hopefully that'll make you go, oh, the sine law is just using the right angle triangles to get across to the other triangle, like we talked about yesterday. What are you talking about? Here, let's say I make up a question. And this could be a question right out of your homework. Not right angled. You're like, that top one sort of looks like a right angle. It can look like a right angle all at once. Until it's got a right angle on there, we don't know it's right angled, okay? So let's say this angle over here is like 50 degrees. And they give you this side and they say this is like 12 meters. Yeah? And then they give you this angle over here. Maybe it's like 65 degrees. And then they want to know this right here, this x here. Yeah? That's what they want to know in all this. I'm going to go through the steps and try to convince you about what's going on with the sine law. Here's my method. Draw on the altitude. Do. And then jumping off the bench as soon as I do that is all the SOHCAHTOA stuff. It goes, well, I can help you now. Now you've built a right angle triangle. And I will go after this height here. Weirdly, okay? I'm going to go after this height. Watch me do it. Sine 50 equals the height of the triangle over 12. Opposite over hypotenuse. Okay? I haven't done much of anything yet. I'm not going to type it in my calculator for the purposes of this lesson. What I'm going to do is go, that means, if I put this over 1, h equals 12 sine 50. Now brace yourself for what's about to happen here. This is big. This is the whole sine law in a nutshell. That means this height here is 12 sine 50, and yes, I could just punch it in my calculator. Here's the sine law. If that's 12 sine 50 in that triangle, then in this triangle over here, this is also 12 sine 50. I hope that does not blow your brain up. I hope you're like, yeah, obviously, if the height is 12 sine 50, the height is 12 sine 50. I could type it in, but I'm not going to. For the purposes of the sine law, I'm not going to type it in. And then I go over to this triangle. And I go, okay, in this triangle, sine of 65, and maybe now you're like, oh, that's why it's called sine law. It's all sines. Every time it's opposite and hypotenuse. So I go over here and I go, that's equal to opposite, which is 12 sine 50, over hypotenuse, which is the x that I'm after in the question. I could cross multiply, and I get x sine 65 equals 12 sine 50. But that's not normally how you see it. Normally how you see it, because it's very handy to use, is we bring the sine 50 over with its x here. And I'm sort of uncross multiplying here. Now look at that formula, and then here comes my highlighter in yellow. Yes? Now anytime you go to do a non-right angle triangle, well, it works for right angle triangles, but why wouldn't you just use SOHCAHTOA? Look at, it's all right here. Wake up right now. Missed everything. Was falling asleep all through this class. Watch this. X over sine 50 equals 12 over sine 65. It's good, right? It might be easier than SOHCAHTOA when it all comes down to it. It has a weakness. It has a weakness. You better have a matching pair. What do we do if there's not a matching pair? Come back tomorrow. We got sine law. We'll get coleslaw. Coleslaw? Coleslaw. You're bringing coleslaw tomorrow? Coleslaw, yeah. So let's not get out of our lane. Today, there'll be a matching pair. And as long as there's a matching pair, we go x over sine 50, 12 over sine 65. We can actually flip both sides, and I think the lesson does. It flips both sides. It puts the sines on top. If you were going after angles, maybe you'd just like to flip it all over. The note really tries to get you to do that, even though if you're a good cross multiplier, you don't care where this stuff is. Yeah, I'll just cross multiply. I don't care. Yeah. Okay, that was me trying to teach sine law and how to manage ridiculous notes like this with all sorts of letters that look like, wait a minute, is alpha-getty still a thing? Do you have alpha-gettys? A friend at my school once had alpha-gettys for lunch and then was sick. Now, this is really disgusting. This is about the most disgusting thing you can throw up is alpha-gettys. But it happens in algebra sometimes where a page like that, it just looks like my friend puking alpha-gettys on your page where you're like, I didn't follow any of that. You take it home. You don't get wound up. You don't go, oh, I guess I'm not going to university. I'm never going to be an engineer or whatever your story is. Just do it with numbers and go, oh, I get it now. That's just where the numbers go. Woo! Some details. Get your pencil out. The sine law. In any acute triangle, the ratio of each side, it's the wrong word. It's the wrong word. It doesn't matter, but it's the wrong word. It doesn't have to be acute. This word's supposed to be oblique. Oops. Sorry, we're making all new notes this year. We're trying to revamp everything, and every once in a while a word gets messed up. It doesn't have to be acute. I don't want you to go home and think it has to be an acute triangle. Oblique is the word for not right-angled. It actually works for right-angled triangles too, weirdly. But oblique is the word when it's not right-angled. So all I'm saying is, even if you don't have a right angle, sine law can help. The ratio of each side to the sine of the opposite angle are equal. I said it fast on purpose. Saying it fast is actually better. The ratio of each side to the sine of its opposite angle are equal. So let me do it again. Maybe you do it on your page too. Maybe you do it with circles. Okay? Look. BB. BB. Yes? BB. That's how we'll label from now on. That way this all works out very tidy. And then AA. And then, what do I got left to highlight? I'll go green. CC. C. Cookie. Sesame Street flashbacks here. And again, yes, I know about the C's. It's unfortunate. Maybe you need, oops, don't even start. See, right here, C, C, yeah? I think you're probably going to want to take that angle C and go C, yeah? Then you can see the difference. When finding sides, you can use it this way. When finding angles, you can use it that way. I don't do that. I do the first one every single time. I'm good at cross multiplying. I don't care. The note is trying to help you, though. It talks about putting the unknown on the top to help out your cross multiplying a little bit. I guess so. If that's what you need, that's fine, okay? 2 examples and we go home. Isn't it? 1, 2, and we're done? Yeah, it's pretty nice. Wait till you see one. If you're not convinced, wait till you see this actually in action. So, given triangle ABC, got it. It's already labeled for, no, come on. C. Change that angle to a big C so you can see the difference. Ha 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 ha. Find the lengths of side A and side B. Looks impossible. I could divide it into 2 right angle triangles and then go all through the steps, and sine law goes, what are you doing? I did that for you. I'll do all those steps for you. Just use the sine law. Write out the sine law equation for the triangle. Okay, we are looking for, what do you want to go at? It doesn't matter in this question. You can go after A first, or you can go after B first. Which one do you want to go after first? A, why not do them in order? Toughest question of the day. Which side is the A? Yeah, sort of, yeah, I know what you're saying. Unfortunately, the hypotenuse word is out the door. There's the little a. We always go AA, BB, BB, CC, yeah? And then, so this one's the little b. So I'm going to go after A first. Is sine law going to work? See, I'm starting to teach tomorrow's lesson. Is sine law going to work? Do I have a matching pair? Let me get my highlighter out. CC, yes. Sine law will work. What if it doesn't work? Come back tomorrow, and we'll make some coleslaw. Yes? We decide we're going for A, so we put A on the top of the ratio. You don't need to do that if you are a good cross multiplier. And what you get is, get ready for this, it's beautiful. A over sine A equals, because I'm going after A, so I got the A's. Which ones do I have? C equals C over sine C. You happy? You should be happy. Most trig people are happy here. They're like, I like sine law. It might even be better than Sakatoa. Excuse me, sorry. Very excited. So I fill in what I know. A over sine 45 equals, what's C? 9 over sine 70. My A and 9 look the same, don't they? That's one of my many algebraic weaknesses. I'm bad for A's that look like 9, so let me be a little more careful there. A 9. Yeah? And then, okay, good. You said it out loud before. Didn't even ask. And then you cross multiply. Yes? So I get A sine 70 equals 9 sine 45. And I like solving. You could pump in 9 sine 45 to your calculator and get the decimal answer, but then you got to write it all down. You got to carry all around the decimal places. I'm a big fan of going, I'm not typing this in until I've isolated A. So A is 9 sine 45 over sine 70. If you need to get the decimals of each one and then do it, I love it. I love you for doing it. But maybe you like this better. Let me bring up my calculator on the screen and show you how to type this in a good calculator. And tonight's your night. If your calculator is a piece of junk, sit them down, have a good talk with them. Say, you know what? It's not you, it's me. I just think we should see other calculators. That's a breakup speech if you ever need one, by the way. It's not you, it's me. Okay, here we go. Fraction button. So good. 9 sine 45 all over sine 70. On a good calculator, you can see all of that on the screen, so you know it matches what you have. Fraction display. Aren't you happy? Yes? You need to travel with your calculator from now on, too, you cell phone people. Leave your cell phone at home. Bring your calculator. Equals. Do you get 6.77? I'll write down the second decimal place only if you're comparing with on your calculator to make sure. Yeah? This particular question didn't have units, but you'd write the units there. Centimeters, meters, millimeters, miles, whatever. Next, this question said, also find C, B. So we go through the whole process again to find B, but it goes very, very quickly. Sine law questions usually, wham, wham, wham. Ready? B over sine B equals C over sine C. Giant C there. So now I'm going after B's. B over sine 65. Get ready, I'm going to ask you this time. Somebody shouted it out last time, which was awesome. But this time we'll get someone to think about it and tell me what to do here. I'm not waiting for someone else to answer. I'm shouting it out right now. Cross multiply, right? That's why I beat cross multiply to death. It just keeps being useful, this cross multiply move. So I get B sine 70 equals 9 sine 65. Did I leave enough room here? I don't know if I did. B equals 9 sine 65 all over sine 70. B equals, I'll find it. I won't even charge you for it. It'll be a freebie. It's a freebie. all I got. I got B. It's all letters and numbers. What jokes am I supposed to make? I need new material. All right. I'll work on it. 8.68. And the only reason I did extra decimal places this time was so that you can compare with what you pump into your calculator and make sure you get the same as me. You're happy? You mostly should be. So I just go A over sine A equals B over sine B? Cross multiply? Yeah. Sine law is very repetitive. It plays out the same way every time. The only fly in the ointment is, what if I don't have a matching pair? Come back tomorrow, and we'll take care of non-matching pair situations, okay? So let's go into a question and approach it like we don't know what's happening, okay? Do you need more time here? Do you need to be quiet? Yes. I know the note's all there. I'm trying to jump ahead 2 lessons where you might have trouble deciding what to do here. I'm going to start teaching that thing. Remember factoring? We had to think through what will I do and when. So let's just put the whole lesson on the shelf and just look at this. First question. Is it a right angle triangle? No, we don't know what it is for sure. So SOHCAHTOA is out, hypotenuse is out, Pythagorean theorems all out, all on the shelf, which is really scary. The only thing we have is
the drawing the line thing to make it a right angle.
Yes, which results in the sine law. Yes? And then you're like, okay, come on, sine law, come on, sine law. Is there a matching pair? I get out my highlighter and I go, do I have a matching pair? Side with its angle. BB, BB, BB. Yeah? And you can literally just do that right to your triangle and go, there. Everything's going to be fine. It's going to be sine law. So that's the thinking that's going to go into this as random triangles get slapped on your page in a couple of days and you have to decide. So it's right angle, not right angle. Not right angle? Come on, sine law. And if not, I'll show you something new tomorrow. But tonight, sine law should work. I'll show you a tricky one. As soon as I finish here, make sure to remind me. Show me a tricky one. As tricky as it can get tonight. Okay, I will. I'll show you a tricky one. So, it says, given triangle ABC, find the measure of angle A and angle C. Write out the sine law equation for the triangle. We are looking for A, capital A. So put A on the top. I don't know that you need to do that. That's just if your cross multiplying is not strong. So you could write the sine law this way. You could write sine A, it's easy to memorize by the way, over A equals sine, hang on, which one? B. That's what I was given, so sine B over little b. Let me label everything. If that's big B, this is little b. If that's big A, this is little a. Clever labeling. Somebody a couple of centuries ago went, hold on everybody. Let's just start labeling them straight across from each other. Won't that be easier? And then for centuries, we've been doing it the same way. Substitute the values given. Oh, I don't know A. I know, that's what you're trying to find out. And you think that's no big deal, but I want to tell you about that for chem and physics next year. You're like, but I don't know that value. I'm like, I know, it's the unknown. You should not know it. That's okay for it to be unknown, because it's unknown. Little a, 23. Big B, 36. Little b, 16. It's almost more difficult to write than just look at. Look at it. Sine 36 over 16 equals sine A over 23. You just, yeah? It's almost impossible to get students to write the formula for this every time. It's easier to write without the formula once you really know sine law really well. So, now what? Cross multiply. So I get 16 sine A equals 23 sine 36. Get ready. Lesson is not over. We need someone clever here. Like, well, it's just cross multiply and divide. I'm like, yeah, I know, but look, Mr. Todd, there's no A on my, well, there actually is an A on some calculators. It's not helpful in this situation. Mr. Todd, there's no A on my calculator. What do? I don't press A. I can't do A. The thing. The thing with the thing.
Inverse sign.
Yeah, the shift sign. This time someone did sine A and they got this mess. We want to know What was it before it started? What's the angle? And maybe now you're at the point where it's like, I'm just going to write that down. If I'm finding angles, I got to use the inverse buttons. If I'm finding sides, I don't need to. So here I'm doing A equals sine inverse. And again, if you would prefer to get that all as a decimal, if that makes you feel better, I love it. I love you for doing that. I'm lazy. I'd rather solve for it. I'd rather type it in once. And in later grades, we may want to get good at algebraically getting this all as one giant thing and then type it into our nice calculator. I'll help you. I'll speak to your calculator. If you have to break up with it, I'll be like, I'm sorry. She tried, but you didn't learn to grow. So you got to go. See you later. Ready? Here we go. Sine inverse, bracket, fraction. Oh, this is fun. 23 sine 36. Denominator 16. Answer, hold on. Let's make a prediction. Do you think it's going to be bigger than 36 degrees or smaller than 36 degrees? Larger. The side's larger? The angle would have to be larger. Okay, good. Small little sidetrack there. 57.66. I'll just go 57.7 degrees. I'll give the extra decimal place just so when you compare, you're seeing you get the same thing. But that is not all. No, that is not all. This said find angle A and find angle C. Let me label angle A on there, and hopefully we got somebody who knows exactly what to do. They realize they don't have to do sine law again. If we flipped it, if we did both of them flipped over, you'd get the same thing, yeah. You don't have to put the unknown on the top. That's just a convenient way to do it. Yes.
Do the sum of triangles.
Sum of the angles of a triangle. So what am I after? C equals 180. Subtract the 36. Subtract the 57.7. Yeah?
I didn't get 57.7 on my calculator.
Oh, did I type it in wrong?
I don't know if you typed it in. Did I type it in wrong?
I don't know. Let's find out. Did anyone else type this in?
Yeah, that's the right.
Did you get 57.7? All right. By democracy, I'm right. No, math is not a democracy. Let me just take a look at your calculator and see what happens. 23 sine 36. Oh, I know what it is. If you use that fraction button there, it does sine 36 over 16.
Oh, okay. So I got to do like.
I think a divide will do it. Yeah, a divide will do it. Or you've had a good run.
Yeah.
You've had, here, a loaner for tonight. Let me loan you this. And unlike future boyfriends and girlfriends, you shouldn't do what I'm about to suggest here. Why don't you just try this for a night? Don't do that. Only do that with calculators. I'm not done up here. Hold on. $86.3? I don't know. Oh, you took a guess. 80, 93.7. Is it 86.3? It's good. He's good. Oh, it's so easy. I'm not going to do my homework. Are you out of your mind? When the homework's easy, do it. It doesn't take long, and then you're ready for the harder stuff. Like, what are you talking about? It's insane. Ms. Todd, how can this get tricky? Here's the only tricky thing. I'm going to carefully make up a question that's a tiny little bit tricky. Tricky. Is that a new joke? Does that count as a new joke? But now you're like, yeah, but now you've used it up. Okay, watch me build this, okay? So that you're really ready for it when it happens to you. Could be in your homework tonight. Are you watching? Shh. trying to help you with your homework, friends. I don't have to do this homework. I've got all my credits. Do you have, okay, and they want B. Do you have a matching pair of angles? Or sorry, matching angle side pair. You got 10, but you don't have this angle. You got B, you don't have B. You got this angle, but you don't have this side. And yet it is a sine law question. Mr. Todd is not a liar. What should you do first here? Sum of angles gets the third angle. Maybe that should be step one. Before all this stuff goes, check if I can get all the angles first. I'm not even going to really look at the question until I check if I can get all the angles. And then this is 180 minus 65 minus 53, which is 62. Then you can start the question. Okay? So that's the only hiccup. Is that tough? No, but it will drive you nuts. You'll try and you'll be like, no, Mr. Todd said you need matching pairs. I don't have matching pairs. I'm like, yeah, but they add to 180. And you're like, oh, stupid math. God, geez. God. Homework, very fast, should be. Yes? You will do it? Then you'll finish your practice quiz. Solutions already up online on yesterday's thing. Lots to do. No online quiz this chapter.